A locomotive is the powerful vehicle at the front of a train which pulls the cars along the track. Sometimes there's a second one pushing from behind as well. Passenger train locomotives are smaller and designed primarily for speed. Freight locomotives pulling rail cars are significantly larger and stronger. Heavy hauls are mammoth freight locomotives designed for North America, where tracks are wider and stronger than in most other parts of the world. Those smaller yellow locomotives are for the European market. The larger gray ones, to the right, are heavy hauls. Workers weld together massive pieces of steel to construct the locomotive's structural underframe. At each end, they insert a giant steel pin through a hole in the underframe's floor. For now, they weld the pins partially to tack them in position. Lifting and maneuvering it with giant trunnions, they flip the underframe so that the protruding side of the pins is facing upward. A crane system transfers the underframe to another area to complete the welding. The pins require exceptional bonding because they connect the underframe to the wheel frames. An automated welder circles each pin repeatedly, progressively building up a 2.5 centimeter thick weld. They make the same size weld on the other side of the pin. All the welded steel parts are exceptionally thick, rendering the underframe strong enough to pull 454 metric tons. Next, they install the air reservoir and pipes for the pneumatic brake system and a 20,000-liter fuel tank. Then they assemble the locomotive's 6 traction motors. Each one generates 750 horsepower, 3 times more than a typical car, giving the locomotive 4,500 horsepower strength. To build each traction motor, they bolt coils of wound copper into a cylinder called a stator. Then they lower another cylinder, called an armature, into the stator. Powered by an alternator, the coils produce an electric field that rotates the armature, turning components which propel the locomotive. Workers lubricate the wheels. Then, using a strong press, fit 2 on each of the vehicle's 6 axles. Each wheel is a meter in diameter and weighs about half a ton. The axle has a large gear that turns both wheels. This finished unit is called a wheel axle gear assembly, WAG for short. Workers install a WAG onto each of the 6 traction motors. The WAG's gear engages with the traction motor's gear, so when the motor runs, that gear turns, which then rotates the WAG gear, which turns the wheels. So now there are 6 WAG and traction motor combinations. Workers divide them into 2 groups of 3, then bolt each trio into a frame called a bogie. So now the locomotive has 2 bogies, each with an air-driven brake system built into it. Until this point, the bogies have been upside down. Now a crane flips them right side up to prepare for the final assembly of the locomotive. They position the 2 bogies next to the underframe at opposite ends. Cranes then lift the underframe and slowly lower it onto the bogies. The pivot pins protruding from beneath the underframe drop into receiving holes in the bogies. Next, they lower a giant alternator onto the deck of the underframe. It powers the traction motors as well as the control systems and other auxiliary equipment. This 16-cylinder, 4,500 horsepower engine drives the alternator. Next, the operator's cab. It's insulated for sound and sits on a shock absorber system. Then the various electrical hookups, including these thick cables. Each one contains more than 1,000 wires, carrying nearly 10,000 amps. Now a hood goes over the engine and alternator to protect them from the elements. From here, the locomotive goes to another department for paint and decals. The finished locomotive is almost 23 meters long. Fueled up, it weighs 204 metric tons and, depending on the terrain, can haul a train up to 1 kilometer long.